Greetings children, welcome to the e-learning class of lines and angles, that is unit 3rd. We are in the period 3 of 4 children. Observe these types of lines. Which are the types of lines you have observed? If I tell you to draw any two types of lines, you may draw like this, that is PQ is one line and RS is another line, or AB is one line and CD is another line. Like this you may draw, or you may draw like this also, MN and OP. Children, observe here, there are different types of lines here. In your notebook also there are lines, railway track lines, the lines in the tiles, the edges of the tiles, the lines in grills of your house, lines on the road also. You may observe different types of lines here children. Observe here, the grills for the stairs you may observe, and the grills, that is the gate, you may observe here also. If I tell you to draw lines like this also, that in Rangoli pattern also you may draw, or you observe in the scissor, the edges of the scissor also. Children, these types of lines, when these two lines, that is AB and CD are the two lines which are intersecting at O. If any two lines intersect at a point, then those lines are called as intersecting lines. Understand children? If any two lines intersect at any point, then those two lines are called as intersecting lines. Another type of lines are there. Observe here, this is PQ and RS are two lines, where if I extend PQ and RS on both sides, it won't meet anywhere. Observe here children, it is not meeting at all. Then these types of lines are called non-intersecting lines, or it may call as parallel lines. Observe here children, the distance between PQ and RS is same wherever you measure. Observe here, it is same length here and it is same length there also. Observe children, the distance between any two lines is not changing, then those two lines are called as parallel lines. Observe here children, if any two lines are intersecting by third line, that is PQ and RS are two parallel lines, where LM is a line which is intersecting PQ at O and RS at T. Here PQ and RS are two lines, but these are intersecting lines, these are not parallel lines, but LM is a line which is intersecting PQ at O and RS at T. This line, that is LM line, is called as transversal. Observe here children, LM is called as transversal. Here this transversal LM is making 8 angles for two lines, that is at O it is forming 4 angles, LOP, LOQ, OQT, POT, 4 angles, and here similarly OTR, OTS, STM, RTM, it is making 4 angles, total it is making 8 angles children. So LM is called as transversal. If a line intersects any two lines, that is parallel lines, or it may be intersecting lines, if that line intersects any two lines at two distinct points, then that line is called as transversal. Here LM is a transversal children. Now let us do this activity and you do with me also children.
Dear students, let us do an activity. When a transversal meets two straight lines at two distinct points, it forms 4 angles around each intersecting points, and thus it forms 8 angles. Observe, at E it forms 1, 2, 3 and 4, and at F it forms 5, 6, 7, 8. We know that angle 2 and 4 are called vertically opposite angles. You are familiar with these angles. Observe 1 and 2. What do we call the angles 1 and 2? Yes, adjacent angles. And also the sum gives 180 degree, hence these are also called as linear pair of angles. Along with these, we can observe few more pair of angles. I help you to recognize these angles, children. Observe, angle 3 and 7 forms English alphabet F shape. These lie on the same side of the transversal. These are called as, the F-shaped angles are called as corresponding angles. This F may be like this. If you reverse it, we get one more pair of angles, that is 4 and 8. Like this, we have one more pair of angle. Totally, we have 4 pairs of F angles. F angles are known as corresponding angles. In the same way, if you observe, we get one more alphabet, that is Z-shape angles. Here, angle 4 and 6 forms Z-shape, and these Z-shape angles are called as alternative angles. Can you recognize one more pair? Yes, that is 3 and 5. These Z-shaped angles are called as alternate angles since these angles lie on the same side of the transversal. These are called as interior alternate angles. Children, these Z-shaped angles and F-shaped angles are very important to understand properties of parallel lines and theorems on parallel lines. So, if a pair of F angles are equal, then we say the two straight lines are parallel. The transversal meets the two straight line, those two lines are parallel. If you observe, if a pair of Z angles, that is alternate angles, are equal, then we say the two straight line AB and CD are parallel. That means they never meet at any point, even though if we extend them to any distance. Yes, so it is very important to know about Z angles and F angles.
Have you done the activity, children? Now, observe here, PQ and RS are parallel lines, LM is a transversal which cuts or which intersects, LM is a transversal which intersects PQ at O and RS at T, children. Now, parallel lines and transversal, these are called as exterior angles, angle LOP, that is we may say it as angle 1, and LOQ, that is angle 2, which is on the exterior side of the parallel lines, that is outer side of the parallel lines, hence they are called as exterior angles. Here RTM and STM are exterior angles. There are 4 exterior angles, angle 1, angle 2, angle 8 and angle 7, children. In the same way, interior angles, just opposite to exterior angles. Observe here, children, angle 3 and angle 4, that is angle QOT and angle POT. Similarly, yes, you are right, angle 5 and angle 6, that is angle OTS and angle OTR. These are interior angles, children. In the same way, corresponding angles, these are the different angles formed when a transversal intersects any two lines. It may be parallel lines or it may be intersecting lines. Here corresponding angles means angle 1 and angle 5, they are corresponding angles. In the same way, angle 2 and angle 6. In the same way, angle 3 and angle 7 and angle 4 and angle 8. There are 4 pairs of corresponding angles, children. Now, alternate interior angles. You know what are interior angles? Now, we are finding alternate interior angles, you can easily understand what are alternate interior angles, that is angle 4 and angle 6. In the same way, angle 3 and angle 5, these are the alternate interior angles, children. Now, alternate exterior angles, you already know which are exterior angles here, children. Exterior angles 1 and angle 7 are alternate exterior angles. In the same way, angle 2 and angle 8 are alternate exterior angles, children. Now, interior angles on the same side of a transversal. This is a transversal, LM is a transversal. On the same side, interior angles on the same side of a transversal means angle 4 and angle 5. In the same way, angle 3 and angle 6. Right, children, you are correct. These are the interior angles and they are consecutive interior angles or allied angles or co-interior angles. These angles are also called as interior angles on the same side of a transversal is also called as consecutive interior angles or allied angles or co-interior angles also, children. Now, axiom 3.3, we have discussed axiom 3.1 and axiom 3.2 in our previous class, children. Now, what is axiom 3.3? What it says? It says if a transversal intersects two lines, then each pair of corresponding angles are equal. We have discussed different types of angles formed when a transversal intersects two lines. Now, if a transversal intersects two lines, then each pair of corresponding angles are equal. This is axiom 3.3. Let us see, children. This is also known as corresponding angles axiom. We mention it as corresponding angles axiom, which means the statement you have to remember, children. Now, let us see the corresponding angles here, angle MTR and angle POL. These are the corresponding angles. Let us check whether they are equal or not. They are telling, that is axiom is telling angle MTR is equal to angle LOP. Just check, children. Yes, it is coinciding, it is superimposing on each other. So, those two angles are equal. So, axiom we have seen, children. Now, the distance between RS and PQ, measure it. It is same everywhere. Then observe here, children, those are parallel lines. Let's do one activity, children.
This is a ruled shade paper you use to take down the notes. In this, every horizontal line is parallel to the other line. Draw two straight lines, then those two lines becomes parallel lines. Now draw one transversal. With this, you can verify that in any two parallel lines, a pair of corresponding angles are equal. Observe, children, here. Yes, the corresponding angles are equal. Now, in the second figure also, you observe I am going to show two pairs of corresponding angles are equal. You can observe the blue shaded color and the black shaded color. The blue shaded color are equal and the black shaded color are equal. By this, we can say that when a transversal intersects two parallel lines, the corresponding angles are equal.
Have you completed the activity? It's nice, na? Now, axiom 3.4, what it says? If a transversal intersects two lines such that a pair of corresponding angles is equal, then two lines are parallel to each other. In our previous axiom, only we saw that we have noted that if the corresponding angles are equal, then those two lines are parallel. We measured the distance between those two lines, though they are parallel or they are non-intersecting lines, children. So, now it is easily we got it. Observe this video, children. Observe this video, children. The corresponding angles are still not equal? Yes, they are equal. Observe the distance here, children. The distance between those two lines, that is EF and AB, it is 3 units. So, if corresponding angles are equal, then those two lines are parallel to each other. If a transversal cuts any two lines, if corresponding angles formed is equal, a pair of corresponding angle formed is equal, then those two lines are parallel. Observe here, children, I am extending both the sides, say still the distance between those lines are equal. Now, next, let us observe here, children, alternate interior angles. We know what are alternate interior angles. Angle 4 is equal to angle 6. In the same way, angle 3 is equal to angle 5. Observe here, children. Angle 4 is equal to angle 6, angle 3 is equal to angle 5. Next, there is a theorem. If a transversal intersects two parallel lines, then each pair of alternate interior angles are equal. Here we observed it diagrammatically, children. If a transversal intersects two parallel lines, then each pair of alternate interior angles are equal. Let us prove this. PQ and RS are the two parallel lines. LM is a transversal intersecting PQ at O and RS at T. Now, data is given. PQ is parallel to RS. Yes. LM is a transversal intersects PQ and RS parallel lines at O and T respectively. Now, what we have to prove? We have to prove angle QOT is equal to angle OTR and angle POT is equal to angle OTS. Let us prove, children. We know that angle LOP is equal to angle OTR. Why? They are corresponding angles. In our previous axiom, if a transversal intersects two parallel lines, then the corresponding angles are equal. Hence, angle LOP is equal to angle OTR. Now, angle LOP is equal to angle QOT because they are vertically opposite angles. We already know it, children. So, from 1 and 2, we can conclude that angle QOT is equal to angle OTR. In the same way, we can prove that angle POT is equal to angle OTS. This is how we have to prove, children. It is a very, very simple proof. You have to remember those angles and those relationships, children. Now, there is another one theorem, that is theorem 3.3. If a transversal intersects two lines such that a pair of alternate interior angles are equal, then those two lines are parallel. Observe here, children. It is corollary of previous theorem. So, again same diagram, data it is same, PQ and RS are parallel lines. LM is a transversal, intersects PQ and RS parallel lines at O and T respectively. Angle QOT is equal to angle OTR, which is given. What we have to prove? We have to prove PQ is parallel to RS. Proof. Angle QOT is equal to angle OTR. Why? Data, it is given. The alternate interior angles are equal. Now, angle LOP is equal to angle QOT. Angle LOP is equal to angle QOT because that is also data. Now, from 1 and 2, angle LOP is equal to angle OTR. Angle LOP is equal to angle OTR. That is axiom 3.3. Hence, PQ is parallel to RS, children. Now, theorem 3.4 says, if a transversal intersects two parallel lines, then each pair of interior angles on the same side of transversal is supplementary. Supplementary means if we add those two angles, it must be equal to 180 degrees, children. Now, let us see, children. PQ and RS are the parallel lines. LM is a transversal which intersects PQ at O and RS at T. Interior angles on the same side of the transversal. Observe here, children. Angle 4 is equal to angle 6. Yes. but angle 4 plus angle 5 is equal to 180 degree, because RTS is a straight line. When we add those two adjacent angles, it must be equal to 180 degree. Angle 4 plus angle 5 is equal to 180 degree. We know that angle 6 plus angle 3 is equal to 180 degree, and this is how we found out, children. So, next there is one more theorem, that is, if a transversal intersects two lines such that a pair of interior angles on the same side of a transversal is supplementary, the corollary of previous theorem, theorem number 3.4. If a transversal intersects two lines such that a pair of interior angles on the same side of a transversal is supplementary, then two lines are parallel to each other. Observe this video, children. Yes, you are observing, if I add those two angles, it is 180 degree. Yes, the distance between those two lines is same, 3 units, then those are parallel lines. If the sum of these two angles is 180 degree, then they are parallel. If it exceeds, then they are not parallel lines. Observe here, children, it is exceeding, but they are not parallel lines, they are, yes, observe here. Now it is parallel when those two, the sum of those two angles is 180 degree, children. Next, theorem 3.6. What it says? Lines which are parallel to the same line are parallel to each other, which means there are two parallel lines. There is a third line which is parallel to first line. Then those three lines are parallel to each other. Let us see diagrammatically, children. Observe, PQ is a line, RS is a parallel line to PQ, whereas TU is a line which is parallel to RS. Now there is a transversal MN which cuts at ABC respectively. Now find the angles. Angle 1 is equal to angle 2. Yes. Same. Angle 1 is equal to angle 3. Yes. Therefore, angle 2 is equal to angle 3. This is how it can be represented, children. Now it is time for solving some problems. In the given figure, find the value of x and y and then show that AB is parallel to CD. Here there are two questions. We have to find out the value of x and y, and we have to show AB is parallel to CD. This is exercise number 3.2, page number 53, question is there. This is the figure they have given. AB is parallel to CD. EF is a transversal which cuts AB and CD at G and Y respectively. Now the angle formed, that is EGA is equal to 50 degree, and they have given CHF is equal to 130 degree, and they mentioned angle AGH is equal to X and angle BGH is equal to Y. We have to find out the value of x and y, children. That is the data given. Now angle AGH is equal to angle EGB is equal to x, y. It is vertically opposite angles. Now it is very easy. Angle EGA plus angle EGB is equal to 180 degree. Why? Adjacent angles, that is linear pair of angles. Linear pair of angles. Now angle AGB is equal to x, that is equal to 180, minus angle EGA, that is 180 degree minus 50 degree. Therefore angle EGB is equal to 130 degree. That is angle EGB is equal to 130 degree. Hence angle CHF is equal to GHD, that is also equal to 130 degree. Y is equal to 130 degree, children, because they are also vertically opposite angles. Angle AGH is equal to x is equal to angle GHD is equal to y is equal to 130 degree because of theorem 3.3. We can solve like this, children. Now therefore theorem 3.3 says if alternate interior angles are equal, then those two lines are parallel, hence AB is parallel to CD, children. This is how we showed here, children. Next question, in the given figure AB is parallel to CD and CD is parallel to EF, therefore EA is perpendicular to AB. If angle BEF is equal to 55 degree, find the value of x, y and z. This is the figure they have given. It is example number 6, page number 52 children. They have mentioned angle x, angle y and angle z here, but they have given only one angle, that is FED angle, that is 55 degree. Now y plus 55 is equal to 180 degree. Y plus 55 is equal to 180 degree because ED is alternate angles on the same side of a transversal. Alternate angles on the same side of a transversal children. Now y is equal to 180 degree minus 55 degree, that is equal to 125 degree. So x is equal to y because AB is parallel to CD, corresponding angles axiom we already discussed here children. So angle x is equal to angle y is equal to 125 degree. Now we have to find out the value of z children. Since AB is parallel to CD and CD is parallel to EF, hence AB is parallel to EF. AB is also parallel to EF. Therefore, angle EAB plus angle FEA is equal to 180 degree because alternate interior angles on the same side of a transversal. So 90 degree plus z plus 55 is equal to 180 degree. Hence z is equal to 180 degree minus 145 degree, that is equal to 35 degree. Angle z is equal to 35 degree. This is how we have to solve the problems children. I solved one problem from exercise and one problem from examples. Now it is time for home assignment children. You have to do this home assignment, the exercise number 3.2, and there are some example problems also. Solve those problems. If you have any doubts, contact your class teacher or contact your mathematics teacher children. They will definitely guide you. In our next class, we will discuss about the properties of angles of a triangle. Now we discuss the properties of parallel lines when a transversal divides parallel lines children, and again theorems on corresponding problems on those theorems children. Till then, this is K.S. Girish, Assistant Teacher, Government High School, Jalige, Devnalli Taluk, Bengaluru Rural District. Thank you children.